So this is the first set of mole conversions on the Unit 3 Practice 8 packet. And in this case, we're going to work through a couple problems in Part A. And so in Part A, I've done some of the work for you, and I scaffolded out so that I can kind of walk you through how to do some of these problems. Again, we're going to be looking at this mole flowchart to help us figure out how to do these problems. But let's just talk about what the problem is asking us to do. So in this problem here, it's asking us to solve for number of moles. So we're looking for number of moles of magnesium. That's our find. And our given is the 3.01 times 10 to the 22nd atoms of magnesium. So that's our given. So that's what we're starting with. So the other thing that we need to remember is that the relationship here is 6.02 times 10 to the 23rd is always going to be equal to 1 mole. Pause for a second. And that's the relationship between 1 mole of anything and any number of particles of that one thing. So if we go and look back at the mole flow chart here, we're really focusing on this on the right side of it. So we're looking at moles and we're looking at particles. So these parts right here, these parts right here is what we're telling us to do. So again, the problem is asking us to convert from atoms to moles. So I'm going to start with particles or atoms, and I'm going to go back this way. And when I go back this way, the math tells me that 1 mole has to be on top and 6.02 times 10 to the 23rd atoms has to be on the bottom, which is what I've set up here. So in this instance, what I've set up here is that hopefully what you can see is that the units of magnesium atoms can cancel out because one's on top and one's on the bottom. And then what I'm left with is moles of magnesium. But what we're really doing for this math here is we're going to multiply straight across the top of this fraction set and multiply straight across the bottom of this fraction set. And really what that looks like is 3.01 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. And so there's a video out there about how to put this into your calculator in scientific notation, and it should be posted on Google Classroom already. But again, if you had Miss Geiger last year, she probably made you download this calculator. It's called Calculator 84 on your phone, so you can do your work at home. And so to quickly walk through that, again, what you're going to do is you would take 3.01. You would hit the second key, which is right in the upper left-hand corner, and then you hit the comma key, which is the key above the 7, and it should give you a number that looks something like this, 0.01 with a lowercase e. You are then going to type 22, and it now looks like this, 3.01 E22. That E means times 10, so we don't have to type times 10. We're then going to hit divided by, and then we're going to type 6.02, second, that comma key, so above the 7, and you should now have something that looks like this. 3.01 E22 divided by 6.02 E, and now I'm going to add 23, and now it looks like this. Again, and at this point, all I'm going to do is I'm going to hit the enter button, and now I'm able to write my answer, which in this case is 0.05. So the answer here is 0.05 moles of magnesium. So that's my final answer for this first problem. So let's take a look at the second problem real quick once. And we're going to look at this one. It's a little bit different than the first, even though the numbers are generally, the math is going to be very similar. In this problem here, we are given 4 moles of glucose, which is C6H12O6, and we are asked to find the number of molecules of glucose, which again is C6H12O6. And again, we need to remember our relationship, and our relationship is going to be 6.02 times 10 to the 23rd particles, right, is going to be equal to, so that's particles, it's going to be equal to 1 mole. So that allows me to know that in this part of my math problem, I'm going to use these two values. So if I go back to the mole flow chart, again, we're starting at moles this time and we're working our way to particles this time. So when I go from moles to particles, I need to have my math set up this way, where 6.02 times 10 to the 23rd is on top and 1 mole is on the bottom. So I'm going to do that right here. So I'm going to put my 1 mole of glucose, C6H12O6, on the bottom, and I'm going to put my number of particles, which is 6.02 times 10 to the 23rd. In this case, particles is going to be molecules of glucose. So that would be C6H12O6. Now, in this problem here, if we multiply straight across, it's going to be 4 times 6.02 times 10 to the 23rd. And if we multiply straight across the bottom, it's going to be 1 times 1. So I don't really have to do any combining of steps here. I just need to also be able to be aware that moles of C6H12O6 are going to cancel out, and I'm going to be left with molecules. So again, when I plug this into the calculator, I'm going to take 4.00 times 6.02, and I'm going to hit the second key in the upper left-hand corner, the comma key, and my keystroke should look like this: 4.00 times 6.02e. I'm going to type 23. So now that lowercase e has become an uppercase e, and I'm going to hit enter. And so what you should have gotten, if you did this correctly in your calculator, you should have gotten 2.408, and then it's going to say E24. So that's calculator language, and we need to translate that into human language, which is going to be 2.4. I'm just going to round this a little bit, times 10 to the 24th, and that's going to be molecules of sugar, C6H12O6. So that's my answer for the second problem. Now, those are the two types of mole conversion problems that have moles going, either working with so again, if we're looking at the mole flow chart, this time we went from moles to particles, and so that was why we had 6.02 times 10 to the 23rd on top. So now I'm going to stop the video here, so it'll be a shorter clip, and then I'll do part B next.